So we're going to start out today by continuing on with our discussion of case studies of key operators in the Flowable class. And if you recall where we'd left off, we had been talking about the generate factory method. And I talked about how you could use it to be aware of back pressure. And so what we're going to do here is show how to apply the RX Java Flowable class and the various features of its operators to show how a subscriber running in one scheduler context in one thread in a thread pool, for example, can exert flow control on a so-called back pressure aware publisher that's running in a different scheduler context. So that's basically the big picture view of this. And as usual, you can get this code in the ex2 project, in my reactive Flowable folder, in my live lessons GitHub repository. So here we are in the ex2 project. Let's go ahead and take a look at the ex2 class. So as we said before, this is going to show how you can essentially have data being published in one scheduler context in one thread, then being sent to a different scheduler context, another thread, where it'll be processed. And we're going to do this in a so-called back pressure aware manner. So let's take a look at this. We're going to keep track of a pending item count so we can see how many items are queued up waiting to be processed. And then we're going to go into the main program. We're going to parse all the command line arguments. There's a whole slew of command line arguments here, as you'll see. We can turn on logging and debugging, output. We can keep track of how many events we're going to generate. I think we're going to do 1,000 in this case, what the maximum value of each generated integer will be, how often we print stuff. And then this particular parameter, the R parameter for request size, is particularly important because this is what's going to dictate how many events can be emitted by a back pressure aware publisher before it has to wait for the back pressure aware subscriber to ask for the next chunk of data to be sent. We're also going to be able to select the scheduler strategy, in other words, where the computations will actually run. So those are the options. Let's take a look at what happens when we start the test. We're going to print out how many of these items we're going to generate. And just for kicks, I will start that running in the background because it takes a bit to run. And then what we're going to do is we're going to make ourselves a special purpose back pressure aware subscriber, back pressure subscriber. And I'll show you what that does in a second. We're going to give it the atomic integer, which is going to keep track of how many items have been emitted, and also the request size, which is one of those option parameters. And we'll take a look at that in a second. The next thing we're going to do is we're going to make ourselves a composite disposable that's going to keep track of this subscriber so that we can free up the resources when we're done with the program. So let's go take a look at the back pressure subscriber. This is kind of cool. So here is the back pressure subscriber. You can see a back pressure subscriber implements the subscriber interface, and it's going to be parameterized with the result type, prime utils result, and it's also going to implement disposable so it can be cleaned up. Inside here we have the atomic integer, which we take from the constructor and stash away in this field. We keep track of the subscription, which is going to be used to control the back pressure. And then we have some Booleans, a Boolean field that keeps track of whether we've been disposed yet. We have something that's going to be the request size. This is important for the back pressure aware dimensions of this particular back pressure subscriber. We also keep track of an atomic integer that knows how many items we processed since the last request was sent. You'll see why we need that in a second, so we can ask for the next tranche when we've processed everything in the current tranche. And then finally, we keep track of the number of items that are processed overall. And we make these things atomic integers because we're going to need to be able to have them called from different threads of control. We don't want them to be corrupted. So let's take a look now. And here is the constructor, which is going to initialize the various fields. The most interesting one here is the request size. Now, the onSubscribe method is a hook method that's defined in the subscriber interface. And it's called back by a publisher when the subscriber first subscribes. When the subscriber subscribes, in this case in blocking subscribe, the onSubscribe hook method gets called back, and that takes the subscription that's handed to it by the publisher, and it stashes it away, and then it sets the initial request size, which is whatever we've given this thing. And let's say, for sake of argument, it's going to be 100. Then we have the various hook methods that get called back, and these would, of course, be onNext, onComplete, and onError. And let's take a look at onNext. onNext is quite interesting. You can see the first thing it does is it prints out some debugging information under certain circumstances so we can tell how we're progressing in our processing. And then we check to see, have we consumed all of the items in this current chunk or this current tranche? Remember, 100 of these things. And if we have not, then we simply don't do anything. We're just going to wait for the next item to show up. If we have, however, processed all of our items, we're then going to go ahead and log that. And then we're going to request the next tranche. So this is how back pressure works. That's how flow control works. So you initially say, I can handle 100 items, Mr. or Miss Publisher, and after 100 items, then I'm going to have to ask for the next tranche before you send many more. And so that's basically what that's doing. That's where the back pressure part gets done. Down here, we have the onError hook method, which is called handle an error by printing an exception. We have the onComplete method, which just says we're done and how many things were processed. And then we keep track of whether we've been disposed. So that's the back pressure aware subscriber. And let's see how that gets used here in a second. So you can see we make one of these things. We stick it into the composite disposable field. And now we're ready to actually run the program. And so the program is going to work as follows. We're going to start by publishing a bunch of random integers on a new thread of control. So scheduler's new thread is just going to make a new thread. And I'll show you that code in a second. The key thing to remember is that all the publishing processing is going to take place in a separate thread or a different thread than the processing of the data that's been published. The data that's been published is going to be handled through flat map and a call to this check for primality method. We will look at that in a second. You will also see that that runs in a separate scheduling context. So the publisher and subscriber are going to run in different threads. So let's take a look at publish random integers and see how this works. So we're going to use the generate method. Remember what generate does is it's going to call this particular, it's going to be called, and it's going to emit things using a back pressure aware emitter. So we're going to make a back pressure aware emitter that's going to emit this many items with this max value, and we're going to keep track of how many items are pending. So let's go take a look at the back pressure aware emitter. In the previous case study, which is the ex1 case study, we talked about a back pressure unaware, non-back pressure aware emitter. Now we have a back pressure aware emitter, and this is what it looks like. So you can see here we're going to make ourselves a new random number generator, and then we're going to return a consumer that will emit values. And this is what the emitter does. It's pretty funky. So what it does is it keeps track of how many integers have been emitted up to this point, and we're going to only emit up to count. Remember, count's going to be 100 for this example. So that's how we limit how many things are published by the publisher. And if we haven't reached the count, we're going to make a new random number. We're going to increment some pending item count statistic keeper. Every so often, we're going to print the item that we just emitted, and then we're going to emit that item. So as long as we haven't reached the count, we're going to be emitting. But once we reach the count, then we're going to say emitter on complete. And so in that particular case, we're done. So that's how many things get processed. And you can see we increment this by 1 each time. So we keep track of that, and that's how we know when we've reached the count. The count is, of course, passed in from the publisher based on the subscription that the subscriber gave when it registered on the onSubscribe hook method. So we're going to generate that many items, let's say 100 just to be concrete. If something goes wrong, we're going to essentially log it and then essentially shut down the stream. And we're going to subscribe this particular Flowable to be generating things on the scheduler that's passed in. And of course, if you recall, the scheduler that was passed in was the new thread. So it's going to run in its own thread. Down here, then, you're going to see how we're going to then call check for primality in flat map. And here's what check for primality does. Check for primality has its own Flowable stream, which is going to take the number that it's given, and it's going to emit that number on whatever scheduler is defined by the options. And in this case, it's going to be, I think it defaults to either the computation thread pool, or it's going to default to some new thread, some single thread. And then we're going to check to see if the number is prime. So we've looked at the prime check a million times, so I won't go back through that again. But this is basically going to be checking for the number is prime on in the context of this given schedule that was passed here. And that's how we're going to do the primality checking. So those things are done in different threads. Notice also that when we're all done, the do finally hook is called, and that will cause the composite disposable to dispose of everything, so we don't have resource leaks. And what kicks off this whole chain of processing is a call to blocking subscribe, passing in this subscriber, and then that will go ahead and start the processing. This will block, and the subscriber, as we just saw, is the one that will be the back pressure aware subscriber, and so everything will start to run, and it should be nice and clean. So that is basically this program. Here's all the other code that we've seen. So let's go ahead and take a look and see what the results were when we run this thing. So you can see we start out with a count of 1,000, and every 100 events we print a diagnostic message. So you can see here that we have published this randomly generated number, this integer, and there are 95 other items that are still pending because we're generating lots of things and the subscriber hasn't started to run yet. And you can see here that this is running in one thread of control, and the other thread is running in a different thread of control. And so we've got different threads running here, and they're processing in different contexts. And so you can see where the processing is getting done here. So this is saying it's not prime, not prime. I think most of them are not prime. Every once in a while, there'll be a prime. And you can see that every 100 of events or so, then we request the next tranche of items. So it's not having the publisher just blast all the events out the way it had done before, but instead, in this case, we're only going to do it each 100 at a time. And so you'll see periodically that we're requesting the next tranche, 100 items, until we have got all the items processed, in which case we are done. So that's the end of this particular example. Hopefully that gives you a better idea of how you can use back pressure aware publishers and subscribers in order to limit the amount of resources that are going to be consumed.